Awesome. Well, hello everyone. Welcome back to week 5. We're like halfway through now, so congrats on making it this far. Hope you've been making it along and making progress on your personal projects. And yeah, I hope you've just been enjoying it. Let's continue on the slides. Today we're going to be learning about servers, HTTP requests, and REST basics, and some backend stuff. So let's start out with some server stuff. Servers are, they're like, there's like this idea in the computer science world about the server client architecture, and it's sort of the way that the web works. Simply put, servers are programs that basically await requests by clients that send these requests. Can be something like a web browser, and they send back responses. Specifically, servers are programs that power basically every website and remote service that you use. They're just programs that are always on and listening, whose purpose is to run like remote and distributed operations for you. They handle incoming and outgoing requests, errors, running functionality that you design, and a bunch of other things. They can be run for programs that you use locally as well as remotely. And as an example, when you play like video games with other people, like if you've been playing Among Us recently, that's basically spinning up a server on their end that handles running everyone's game and the interactions that may happen between each player. There are basically two main reasons that you'd want to have a server as part of your application. The first is that some operations are computationally expensive, and they'd slow down your users' computers, and it would just, it could take a while to compute for each person individually. The second reason is that you might want to hide parts of the application's design from your users, possibly for security reasons. And there are other reasons, like they allow users to connect with each other remotely. Oh, whoops. Okay. A client is a program that makes requests to servers. Servers can also be clients if they need to interact with other servers, but in most cases, they're just standalone programs too. From the example of the game above, the client side of that would be the part of the game that you interact with and in a way download locally, which ends up being like sending these requests to the servers. In the Among Us example from earlier, like specifically your web browser, when you load that page, that would be the client side of the game, or the client side of the server client architecture. The client also acts as a user interface for the app that you're using, and it provides a way for a user to give input to your app. The user experience is heavily tied to both the design of the interface and the workflows that you create. So together, UI and UX make up the user interactivity part of this design process. Now, as you can imagine, with these separate programs for both the server and the client, the interactions need to be pretty carefully planned. Like if, for example, your client is sending data to the server, but the data is missing information or it's just sent in a way that's not really expected, which is actually a surprisingly common problem to have, there are going to be errors. And so if this occurs, depending on the processes you and your company or you and your team use for development, going back and fixing these errors can end up either causing other errors or just taking up valuable time in possibly unplanned work, which you really want to avoid. As you can see on the screen, we have this like plug and socket analogy. It's sort of like building a plug in a socket. If you use some like international adapter or something for like an American socket, you're not like the plug and the socket won't fit together. So you really want to try to avoid and carefully plan out this interaction. Does anyone have any questions so far? I'm going to continue. Hosting is a pretty important part of the server side of the server client architecture. It's the act of starting a server and allowing clients to connect to it. These connections are usually accessible by host names, which is like what you usually type into the search bar when you're loading a URL to go to a website, and IP addresses. If you haven't seen them before, IP addresses are an identification number basically assigned to every device on a computer network, which uses the Internet Protocol, which IP address, the IP a part of that, to communicate and relay information. And in most cases, IPv4, which is a specific version of that, is used, which usually look like 4 numbers from 0 to 255, separated by periods. We'll show some examples in a second. But yeah, often when you try to type in like a website name like C4C or google.com or something, a special service called the domain name service translate that text into an IP address. And if you're interested, on our learn.c4cneu page with what we sent out earlier, you can see some examples of that and just like a more detailed link that we have to check more out about the DNS service. So now these are a couple really common IP addresses. Does anyone know what these are? Or has anyone seen these before? Or does anyone want to guess as to what these sort of do or mean? Yep, Boban said the first one is localhost. 127.001 is localhost, and we'll be getting to that one in a second. We'll go a little bit more into detail on that.
Wait, are they all localhosts?
They aren't all localhosts. The first one's localhost. I'll continue right now, but the second one's actually a computer on your local network, which is in a way similar to localhost. So technically what happens with the second one is local networks are sort of like grouped together compared to the overall structure of the internet. So usually on the same network, computers will be given this 192.168.something something number. 8.8.8.8 is actually an interesting one. That's Google. So if you type in https://8.8.8.8, it'll take you to Google's DNS. So remember that DNS that we were talking about a second ago? That's Google's version of that. And the last one is Northeastern's. Northeastern actually owns this 129.10 and then everything else behind that. So Northeastern's actually got like a couple 100,000 IP addresses, which is really interesting. And if you end up taking the networks course here, you'll learn more about that, and it's really cool. So as we said a second ago, 127.0.0.1 is localhost, and that's an address that's usually used for locally hosted servers, and you can use that to connect and access them on your computer. If you want to access that, you just type in, again, 127.0.0.1, or you can type in http://localhost. And what that'll do is, it's called a loopback address, which means that any requests that are routed to it just don't even leave the computer itself. For simplicity's sake, you can just think of it as a really quick and simple way to access this computer's address, as in like my current computer. If I start up a server, you can just access your server really easily like that. And you'll be using this a lot later. I think you've already used it a bit for the front end if you've been working on your project there. And you'll be using it on the back end and pretty much any other projects that you create locally. Any other questions right now before we move on? All right. Now on to ports. So a port is basically an individual endpoint at a specific address. A second ago, we were talking about like localhost. Localhost has a bunch of ports on it that you can access, and like one program basically can be using a port at any given time. Each program that wants to act as a server can reserve that specific port to be used like throughout its lifespan. Yeah, and as I said, no two programs can share the same port. That's like a very important concept. If if you do try to have two programs sharing the same port, the second one that attempts to use it will get an error and probably shut down. They can range from 0 to 65, 535, which is a huge range. And the ones ranging from 0 to 1024 are commonly referred to as the well-known port numbers. Does anyone know some commonly used ports on your computer? Has anyone seen any ports before? Or heard of anyone? Yeah, Boban said 80. 80 is a really commonly used port. That's the HTTP port usually for when you're starting a server. If you like want to connect to Google or something on over HTTP, you'll type in like Google's IP ://80, and it'll usually connect to HTTP and download the web page through that. You also said 22, which is, yeah, that one is secure shell, which is a very important one. If you're taking networks or computer systems, you'll be using those a lot. So SSH is a very important one, and it makes working with other computers really nice sometimes.
We also, I guess, for 8080, Connor, do you know what that is?
Oh, 8080. I actually don't know what 8080, if there's like a specific program for that, but I know we are using 8081 for our backend here.
I think 8080 is our front end port, right? That we use for most of the C4C projects.
I think we were using 3000 for that one, maybe.
But 8080 is a good one, kind of a classic one for people to use on the kind of like local machine. I think is where that is mostly used.
Mm-hmm. So again, by default, like if you're trying to like work with HTTP or HTTPS or any of these other services that we have here, by default, it'll usually look for these programs on those ports. You can always customize them, like we did to the back end and the front end to run on like ports 3000 or 8081 or something. But these are the defaults for some of the other ones, like FTP, which is file transfer protocol. So you can transfer files pretty easily. Simple mail transfer protocol, which is often used for email, and HTTPS, which is secure HTTP technically. So when you're trying to like access a specific port, just really quickly before we move on, you can access it. I don't know if you can see this right here, but you usually type in the protocol starting out right here. So HTTP : / or you could do like FTP : / or any of the others. And then you type the host name. So in our case, if we're doing something locally, we do localhost, and then a colon, and then the port number. So again, you'll probably be using that a bunch. One quick thing before we go on. If you're developing locally and you want to show your friends how to do it, a really simple program, we talk a lot more about it in our notes that we sent earlier, it's called ngrok. And it allows you to basically like publish your network traffic through someone else's server. It's pretty secure and you can learn more about it, but it's just like a cool little tool that you can use. So recommend checking that out if you want to show someone else your project. Now moving on, we're going to go to HTTP, and actually before we move on again, does anyone else have any questions before we continue? NGROK. So just like that, yeah, it allows you to public network traffic and not have to deal with like the network rules and things like that. It's pretty nice. Yeah. Any other questions before we move on? Okay. Yeah, so again, we're going to HTTP and REST requests. And this is a big part of what you'll want to know here. So HTTP, also called like Hypertext Transfer Protocol, is a protocol for requests and responses in a server client like architecture model like we talked about earlier. In the web browser example from earlier again, the client's request to the server is an HTTP request, and the server provides an HTTP response in a form similar to a string containing like the return data. It provides a few useful pieces of information with it in both requests and responses that we'll use. They both have headers that provide a bit of metadata about the request or response, and an optional body including any data that has to be transferred. The responses additionally have what's called a status code, and that sort of gives you like a quick overview of what happened during the request. Also, as we have on the slide here, there's also HTTPS, which I've received a few questions about earlier throughout the course. And it means, like we said earlier, HTTP secure. And it's how you'd want to make requests to your website outside of development and like in production. But we're going to avoid it for now in the Jumpstart projects because it's sort of like a pain to set up, and it's really not worth it for you to use when you're testing locally. All right, so common status codes, you've probably seen a couple of these before, but again, they're just numerical codes that are returned in a response that indicate the status of the request. Here are a couple of the ranges. Basically, we've got 100, the 100s range are informational responses, which you'll rarely use. 200 indicate successful responses, which are probably the most common. 300s indicate redirects. So if you'd like to redirect your client to go somewhere else and they're using a web browser or something. 400s are client errors. So if your client does something or the front end messes up when sending a response, it's malformed or something like that, you'll usually get a 400. And 500 are server errors. So if your server receives something and it doesn't know how to handle it and it throws an uncaught exception, that's usually when you'll get back a 500. For the purpose of this course, we're only going to be covering the 200s, 400s, and 500s. So if you're interested in the 100s or 200 or if you're interested in the 100s or 300s, go ahead and check it out on the status code guide in our script. And we also have a couple external links that you can use to learn more about that. Does anyone know some common successful responses? Yep, 200 OK is a very common one, probably the most common. And it just indicates that you got a successful request. You got a successful response. Let's go check them out now. So as we just said, 200 OK, Boban, good job. Again, the most common means everything went well. We've also got 201, which indicates that something has been created on the server for you. And 204, which is basically 200, but without a body. You can often use 200 if you're not returning a response body, but 204 is just another way to indicate that it was successful, but you're not returning anything back. Does anyone know some common client error responses? So the 400s. 401 and 404. Yep, those are two important ones. 401 is unauthorized. We'll get to that in a second. 404 is probably what you've seen before. If you've gone to a page and haven't been able to locate anything, it means not found. 403, yep, 403 is also a very important one, means forbidden. All right, let's go on and actually check them out. So one of the ones that you'll probably be using a lot in your projects is 400. It means bad request, and it basically just means that there was an issue with the body of the request, commonly due to invalid syntax or just something was unexpected or something similar to that. We've also got, as was said earlier, 401, which is unauthorized, which means basically that the client needs to log in. 403, which is forbidden, and that means that the logged in user is authorized but doesn't have the right permissions to access this. 404, which means not found. 405, which means method not allowed. If you're using a post request instead of a get request, which we'll cover a bit later. 410 means gone, which means whatever it is you're looking for has been deleted. And my favorite, 418, which means I'm a teapot, and it means that the server refuses the attempt to brew coffee. And yes, that is real. So check that one out. It's the best response code, so love that one. Does anyone know some, this is the last one for codes, but does anyone know some common error codes? Not getting any responses, which is pretty good because you don't want to be sending 500s back unless there's a really bad issue. So 500 is internal server error. That just means like an uncaught exception was thrown by your backend and it didn't know what to do with it. So you just return a 500 saying, I don't know what happened. You've also got, there are like 502, which means bad gateway, but you won't really be working with that probably ever. 503, which means service unavailable, like if the server is overloaded or it's currently down. And 504, which is gateway timeout, which is also probably one you're not going to use really ever. If you want to learn more about any status codes, again, we have some links in the script that we sent earlier that will, they can provide you like a quick overview of them, or even some like the MDN page, I think has a more in-depth one too. So 2 weeks ago, we talked about JavaScript, that was 2 weeks ago. And now we're getting into JSON, which is JavaScript object notation. And it's basically a way of representing data in a very clean and easy to write way, commonly compared to XML if you've ever worked with that before. And you can see an in-depth description of it on the JSON website if you're interested. But going back to the JavaScript tutorial that we had 2 weeks ago, or the JavaScript workshop.
I think Connor's having some internet issues.
It's basically very similar.
We'll give him a second.
To the object data differences to worry about. The format.
Connie, you there?
Yeah, sorry about that. I think Zoom just crashed or something.
I think you should be good now. You want to share your screen again?
Hopefully, we'll see. Might happen again.
You cut off just as you were talking about people recognizing things from JavaScript.
Oh, so it's been a while. Okay. Let's see. Wait, what was I talking about? Sorry.
If people remember the JavaScript workshop from 2 weeks ago, this will look a lot very similar.
Yeah, so if you remember the JavaScript workshop from a few weeks ago, this will be very similar because JSON is basically the same thing as like an object data type in JavaScript just like that whole category of things with just like a few syntactical differences, and we'll go over that right now. So basically it consists of three main categories. The value category, which has stuff like strings, numbers, true, false, and null. The arrays category, which is like, as you can see down below here, you can have arrays and arrays. You can have objects and arrays, which we'll get to in a second. You can have value types and arrays. So like all of these would be valid arrays down here. And finally, we have the object type, which is basically like, remember the object that we worked with in JavaScript, surrounded by curly braces. The only difference is that the key of the object is a string rather than it has to be a string rather than just anything. So here are a couple examples of that. It's like the key value pair kind of thing, or the key item thing. this makes it really, like as I said earlier, it makes it really easy to transfer data in, like in just using generic web architectures. So you'll want to probably keep this in mind, learn how to use it, and yeah, you'll just be using it a lot.
One thing I'll point out really quickly is unlike the JavaScript objects for JSON, you have to quote your keys. So they have to be surrounded by these quotation marks, where JavaScript, it is optional.
Mm-hmm. All right, does anyone have any questions about JSON while we're still on it, or anything else we've gone over? All right, I'm gonna continue. Next, we've got like HTTP requests in general. So there are a bunch of different request types in HTTP. We just mentioned GET and POST a few seconds ago. And a lot of them will be covered in the following lesson. So we'll just have like a higher level overview right here. Each type of request is supposed to represent a different operation in this like idea of create, read, update, delete, which is also called, or like for short, CRUD. And there are a couple of like request types outside of those, but for most cases, you'll just stick with those operations when creating like a web application. GET requests are probably the most common, along with POST, and it corresponds to the read operation of create, read, update, delete, CRUD. So it's generally used when you're trying to get information from a server, or like, yeah, just like read information from a server. In fact, whenever you load a website using a web browser, you're actually sending GET requests to the website you want to access. Your browser handles all that for you. But yeah, it just sends a request and you get that information. There are a bunch of other request methods like post, put, delete, which we'll be covering next week. So be sure to join us then. I think this is the last thing in the HTTP and REST request section. So REST, which stands for representational state transfer. A mouthful. Full web services, as they're called, or web applications. So the server client architecture, like we mentioned earlier, the stateless mechanic a little bit, in that the server doesn't store any context about who the client is. So the clients only know about their session state and contain all the information necessary. And if the server needs to know anything, it's stored usually in like an external program, like a database. Savability or cacheability responses are able to be marked as savable or non-savable so that optimizations can be performed. Layered system, a client shouldn't need to know if it's connected directly to the end user, or sorry, the end server, if there are intermediary services, and a uniform interface, in that the server and its resources and implementation should be decoupled from what is returned from the client. We'll be trying to build our servers by following some of those principles, but they're more just guidelines to keep us to keep in mind when designing everything. So most servers don't actually follow the above, like these rules super strictly. And also these are things that you don't have to explicitly remember. Just having like that general idea is pretty much all you need. So when you're working with requests and responses, you'll be working like sending a lot of requests out. And to do that, there are like some programs that make it a lot easier. In terms of being able to run through the command line on almost every computer, curl, which is a really common tool, is very useful and functional, but it can be a bit complicated. Feel free to try it out on the command line. We've got some, if you read the backend README, there was a command that you send out using curl. And you should be able to curl like pretty much any web page in HTML. But usually when we're sending requests here, we usually like to work with, as Liam sent earlier, POSTMAN, which is a really nice client. And I'll be showing an example toward the end on how to use that. Yeah, because working on the command line can get pretty annoying. So Postman allows you to save requests, really easily update them. And the more you use it, the more you'll learn to love it. It's a really nice tool. All right, so when routing on the backend, actually, sorry, let's step back a little bit. We're working on backend stuff now. And basically, like the biggest idea we're going to be covering here is how routing works. We'll start with the structure of the backend. So if you've taken a look at it so far, yeah?
We'll specify this is the C4C backend, the one that you guys hopefully set up after week 1. So I think we'll be showing some like code demonstrations now, and we'll start working with that Java repository.
Yeah. So we'll be showing an example again using Postman in a sec. So, but yeah, this is the C4C specific backend right now, not just generically backends. So yeah, if you have taken a look at it, you'll notice there are like 3 main directories or modules. One is the API directory, which is where all requests will enter through, and it's the way that external clients will interact with and view the results of our application. The persist directory, which is where all persisting information will live. Starting out, it's like where we'll create our database mocks and just like some in-memory stuff using like lists and hash maps. Later on, it'll be used where like our database interactivity classes and files will be physically placed. Lastly, the service directory is what unifies everything together. Since we want to make sure that the persist directory and API directories aren't dependent on each other, there'll be a few interfaces that are made in those like API and persist directories that will be implemented in service. If that doesn't make sense, we'll be showing an example in the starter code that we give out, so you can check it out there. And this is because some of the operations that we need to perform need to know of both those directories. But yeah, again, those two shouldn't know about each other to make it as like loosely coupled and flexible as possible. Also, if any of you have heard about the model view controller design pattern, like if you've taken OOD, or you might have heard about it in like Fundies 1 or Fundies 2 or online or something, this follows that. Our model is actually the persist directory that deals with representing, it deals with handling the data and processing it and saving it. The view in this case is our API, where it presents data like visually or textually in a way that can be accessed by an external entity like you or another program. And the controller deals with linking up the interactions between them, which in this case is our service module. Does that make sense to everyone? Does everyone feel good about this so far? Yeah, cool. So let's start out with what routing is. Routing in terms of the backend is when we define the actual routes and of our application and the functionality that they provide. Had this protocol, then our domain name, and then our path.
Hey,
and finally the path, which actually is like the resource that you're, oh, is it cutting? Yeah?
Yeah, you cut off a little bit. Yeah, can you just start over on the slide?
Uh-oh. Yeah, sure.
You should be fine now.
So, oh yeah, let me know if I cut out again. So routing is when we actually define the actual routes and paths of the application and the functionality that each of those paths provide. So going back to what we were talking about earlier with the like the ports and things, remember we had our protocol here, our domain name here, our port right between our domain name and the path, and then the path is actually like the resource that you're accessing. Yeah, we'll be showing like a more complex example of this that's got pretty much every part of the URL anatomy, and it'll hopefully start to make sense more around that. So let's check out API main. I'm going to pull this up real quick. Let me just stop the share and get it all ready. Okay, so can everyone see my screen right now? Does everything look
Yes.
good? Cool. So I don't know if you've looked at it before, but this is like the API main. So in API, we've got our API main right here class. And this is what handles like the API side of things. In here, we've got like our port that we're starting on, the default port. You can change this if you want. And we usually pass in like a router, which, yeah, it follows this iRouter interface, which you'll see more when you're working on your backend during the week. To start up the API side of the server, we've got our start API method, which creates a new Vertex object, creates a new HTTP server from that, and gets a router from that Vertex object again too. Right here we have some setup, which basically sets up the cores stuff, which is like, I think it's cross-origin resource sharing, which is basically something you'll need in the future for working with like combining your front end and your back end. It basically like adds an extra layer of security to make sure things aren't used from like unsafe websites, basically. We've got something that starts up our logger. We have a body handler, which deals with gathering the entire body and setting it on the router context. We've got a failure method, which is at the bottom, and we finally got a home route here. So we'll step through that in a sec. And lastly, we start our server up, have it listen on that default port from earlier, and just print out, hey, the program started. I just pulled up the chat. Is it blocking the window at all?
No.
Oh, cool. Okay. Just want to make sure I'm not blocking anything for you all. So let's go back to that creation of that home route. So right here, you can see we're creating this route at, we call the router.route method on the path. So if you remember from earlier, our URL for this program, if we're running it locally, should be http://localhost:8081. And then if that's your entire path, then that'll activate this home route. And so as you can see here, we're setting up this route and we're setting a handler for it. So handle home is called whenever this route is accessed. So let's go down and see what that does. So just a little bit further down, just right here, you can see what we're doing is we're creating a response that uses CTX. It's like a little, this routing context is an object that's passed in that contains some information about how this was called. Like I think it contains like the current route, an object that indicates like allows you to create a response from any data that was passed along with it. And so you can see here, we're setting the status code, putting some header stuff, and then ending the response with this hello Jumpstarters text response. If you've looked around at all, inside of our iRouter interface, we've created a method that handles a lot of this for you, but we just wanted to throw it here so that you can see it. So now let's go through the exercise of creating a route. So if we want to create a route that says hi, with like the path is hi, how would we do that? Does anyone know? Oh. Does anyone know it would go right here? We've got an example right above.
On line 74.
Yep, it would just be router, dot route, hi. Nope. Can't type today, but yeah, so we got router.route hi. So this sets up our route path for hi. And then so once we have that, what do we do with this? Oh. There's a little hint right there, but does anyone know what we do next? Add a source port. I'm sorry, I don't know what you mean by add a source port. If you're referring to the default port that we have above, like this 8081, down here we've got our default port. So this handles making the server listen on that port. So going back here, yeah, so handler, and then down below, I've created this handle hi method. So we'll be referencing that. This is a method reference. You can read a little bit more about that in the starter code that we'll give you. But we'll say this handle hi. So now we've set up that route and created a handler for it. So coming down here, does anyone know how we'd like what we'd actually do to get this handle hi to start responding with something? If anyone's got it pulled up, actually, let's see if I can go to this right now. Okay, yeah. So we have this end method right here, just to show you right now real quick, which will handle setting all these things that we talked about earlier. And you can just use these in your code because it'll be a lot easier than writing this out every single time. So we've got this end method, which takes in a response and a status code. So going back here, we have our CTX response and going back here, response, status code, and body. So we've got our end method. So we call end ctx.response. So what goes next? Does anyone know?
IntelliJ is giving us a hint.
IntelliJ is giving us a hint. Does anyone remember the status codes from earlier? Does anyone? 200, okay. So yeah, perfect. So I'm going to put in 200. And now we can put we're not really going to be dealing with content types in here. So this will just by default set it as a JSON content type, which a string is a valid JSON object, if in a way. It's a valid JSON response. So we won't be dealing with that. But what should we put as our JSON body? If we're trying to return hello jump starters right here, or something like that, or just hi or something, what would we put as our response? Not post. So we're not posting right now. We're just setting this as a get route. So we'll be leaving post alone until next week. We'll just focus on get for now. And setting up the post part of it would actually be part of this router.route. We'd use a different method here instead. But nice guess. So for this, what we're going to say as the response body is we'll just say, hey there, or something like that. So now that we've got that all set up, let's start up our server and try it out. Oh, apparently I've already got it running. Forgot to shut it down from earlier. So if you want to start your server, you can just go to service main, which is all the way in your service directory, and you just hit this green arrow and say run. So let's go back here. Let's make sure it starts up first. So it's started up, and now we'll open Postman. Can you see Postman, or did I select IntelliJ as the only thing that gets shared?
Yeah, we can't see Postman right now.
All right, let me fix that real quick. All right. So you see Postman now?
Yes.
Cool. So let's see. What we'll do is we'll create a new request here. And first we'll start out, just make sure the server's working. So we've got HTTP localhost 8081. So if you remember from earlier, from the README actually, we set up this route, and we have this route. Yeah, we set up this route, and it just returns hello jump starters. So now that we know our server is working, let's try out the route that we just set up. So how do we, what do we type in here? Does anyone know what we type in there to get that route that we just made? Hi, yeah. Good job, Boban. Yeah, so we got our hey there response. So now we know that it's working. Give me a sec. Now we're going to go on to static routing. So static routing, actually, no, sorry, that was static routing. Now we're going to go on more dynamic routes. And this is more like a reference to how we can like add parameters to our route and be able to like work with it through that. So here's what we're going to be doing. We're going to be creating a route that says hi and then has like a variable in the path, which you'll be able to get and use when you're working with it. So starting off, can anyone tell me how this should start off? I'll show you how to do the variable part of it, but like how would you get to this part at least?
Wait, is it? Oh.
Uh-oh.
Is it just root?
Uh-oh. Are you okay? Yeah. You want to just type it in the chat? Or?
Okay. Is it just router.route?
Yeah, so it should be router.route. And then you know what should go here?
Like slash hi, slash
hi.
And then I think.
I'd be surprised if you know this. I haven't shown this, but if you can guess it, that would be amazing.
Like, wait, I think like they said something about it. Was it like $sign or like curly braces? Something that's like.
So you're thinking of string interpolation. This is actually a vertex thing that we haven't talked about yet. So maybe Connor, you should introduce that.
Yeah. I just wanted to see if anyone knew of it because it'd be awesome if you did, but no worries if you don't. So what we actually do is if we want to create a variable in the path, we add a colon and then the variable. So let's say name or something like that. So what this does is it basically like allows us to set, like the colon identifies the name as a variable and we'll be able to get that later on. So now if we come here, oh, whoops. Does anyone know what this should be? By the way, I have down below a handle named hi method.
I guess you just call the method, right?
How would I call the method? If you look up on 84. Handler, awesome.
And this.
Oh.
And like you call the handler method.
Yep. Handle named hi. Handle named hi. Okay. What's going on? Oh, handler. Cool. So we've got this all set up. So let's come down here. And basically what we can do is we can, let's see, we can get that actual variable from it by going, so we can set up our string name variable. And we've also provided another method called get request parameter as string. So get request parameter as string. I think I forgot to import it here, so let me just make sure we get that really quickly. I'm going to go and get it from this really quickly because I know it's in here. So let's just go to the top, drop this in. Request parameter as string. Let's try retyping that. Yeah, so get request parameter as string. And then basically what we do is we pass in the request. So we can call ctx.request, and that returns us all the request information and the name of the variable that we want to get. So if you remember up above, we named it name. So we can just say name. And so that should return us our name. Don't worry if this isn't making sense exactly what this is doing here. We'll show you in a sec with the Postman, like we'll show you an example with Postman. So now that we have that, we can create like a response body. So string response equals hey, and then we'll throw in name, and then we'll just put in an exclamation point. So that'll return hey name with an exclamation point at the end. And don't forget, we'll end it the same way that we did before. So can anyone tell me what we would do here? You can see an example on line 129 here.
Maybe you should end your method.
End. So we'd end the method. Does anyone know what would go first?
Well, it's saying like the response, right? The HTTP
Yes.
response.
Yeah. So do you know where we'd get that from?
ctx.response.
Awesome. Yeah. And then do you know what would go for the status code?
Like, would it be the same as the method above it?
Yep. So 200. And then lastly, we have our RESP that we created right here, right? So does that look right?
Yeah.
Awesome. Okay. So now we've got all that. It takes the name, it gets the name from the request route, and then adds it to a response. It just returns basically the same thing as above. So let's stop and restart the server, pull up Postman real quick. So just to make sure everything's still working, we'll start off with this. So if you can see in the background, the server started. So let's start with that. So we've got hi, returns hey there. So that's still working. And then I can also say Jumpstart. So now if you can see what's going on, remember anything that's like hi slash whatever, this becomes a variable that we can get and do whatever we want with. And in this case, we're just adding it in the response. You can also do things like getting numbers from that, and very flexible once you start using it. Does anyone have any questions about this?
Con, you still there?
Yeah, sorry.
Oh. Uh-oh. When did I? Oh.
You're back. You just were asking for questions.
Yeah. Okay.
Are there any questions?
Yeah. Any questions?
Is there like a possibility to create like subroots, like roots within, right? Oh, it's like glitching for me. I don't know.
We had another route that's like,
Connor, you're there.
Okay. Is it getting better?
Yeah, you should be good now.
Okay. Yeah. So for routes within routes, we could even go like further like this. We could create a new route if we wanted to. That was like, I'm just gonna do that just to change the name, but we could go hi, hello, or like ABCD, and we could keep going as long as we wanted for that. So there's another way. I'll step through it real quick in the end, but you can also append variables to the end, which are optional and you can get, but we won't really be using those in this course. So I'll just skip that for now. You can check it out more in the script, just since we're running out of time. The last thing I'm going to show you right now is I'm going to comment these out real quick, these routes that we just made. The last thing I'm going to show you is how to create a subrouter. And what that allows you to do is, I don't know if this was part of the question from earlier, but you can group a bunch of routes together that have the same start, if that makes sense. So what we'll do here is I've created this subrouter here, this API router, which you can look into more in the starter code we'll be giving out. But it's basically a router where everything inside of this subrouter has this hi prefix to it. So if we go into this, So we've got our hi router. This is our sub router. And we can pass in like a processor or some other thing to work with if we wanted to. But we can do all the same things we did earlier. So like, in this case, this would be our hi route. Since this sub router is mounted at /hi, we assume that everything in this router has hi prefixed onto it. So this is now our /hi route, and this would be our like /name route, right? And I just threw on an extra /welcome there to show that you can like have things after the variable too. Does that make sense at all? Anyone confused? And I'll show an example of how that would actually work here. So remember, I took out these two routes that we made earlier, and I just threw them inside of the hi router, the hi sub router. So, oh, I think I closed Postman. Let me get that back real quick. So now we've got this back up. Our server has started. So remember, we got rid of that hi route, but moved it into the sub router. So if we go like this, it still shows up. It's just going through the path that it sort of takes. Is it goes through this hi, it finds hi right here, goes into this sub router right here. Oh, goes into that sub router, which is this sub router, and then it creates everything in the same way. And now we're just getting the hi route as like a root route of that sub router. To get that name route, we also threw on that extra welcome here. So we'd say, hi, Jumpstart, welcome. And so it throws out, hey, Jumpstart, welcome. Which is a little different from our earlier message, but you get the gist, right? Does that make sense? Yeah? Okay, I'm gonna go back to the PowerPoint real quick. Let's see. Oh, is that the wrong one? Okay,
no,
so.
That's right. Go on.
Okay, so yeah, basically, yeah, as we said, the sub router, basically it adds like a custom prefix, and it's like a custom router. And what's interesting is that you can group all similar routes together, all routes that have the same prefix, each of routes with the same prefix, which can get annoying. And it also allows us to define behavior that applies to like all requests, which is really useful, but we're not really going to get into that because it's sort of outside of the scope of this right now. The last thing I have, just to finish up really quickly, the API shouldn't know anything about the database, and the database shouldn't know anything about the API. So a lot of the time, processing needs to be done in the service directory using methods that are provided by those like database and API modules. This can make things a bit complicated though, since the API module needs to be able to call these methods, but not really know how they're implemented. So it's accomplished by creating an interface, which you'll see more about in each of those like modules that service depends on, and actually implementing those interfaces in the service module. Without needing a of this in the code that you'll be given for this week. So next week, we'll be doing the advanced backend workshop, where we'll be doing some testing. We know it's not as fun, but there are actually some pretty cool tools that you can use, which we'll be demonstrating. And we'll also be going over the other request types that we talked about today, or mentioned today. We also have some events upcoming. We've got technical interviews with Brandon Lang on the 29th, Thursday the 29th, this Thursday at 6 p.m. And next week on Thursday, we've got Design 101 with Rain, who actually makes all of our PowerPoints, also at 6. So be sure to join for those.
Yeah, I'll point out.
And you did it.
Yeah, I'll point out the Thursday workshop we'll be posting in that general channel on the Slack. You guys will be able to see the link there. It'll be super useful if you're looking for a co-op or will be next semester. just going over like how you prepare for technical interviews and kind of how to approach that.
Yeah. Thanks everyone for coming. We hope you enjoyed. Definitely stop by for that Thursday workshop. It'll be a lot of fun, a lot of interesting stuff. I think Brandon just got his co-op at Microsoft actually, so definitely knows what he's doing there. And yeah, let us know how we did. And if you have any questions about anything, be sure to reach out. We'll be sending the starter code for this week out in probably like an hour or two.
Okay, thank you so much.
Thanks, everyone.